Hello students, welcome ulit sa online tutorial natin. So continue tayo for problem number 25. So the cross-sectional area daw of the members in the steel truss shown in TOS 006 is 400 yung area, and then 200 GPa naman yung modulus of elasticity. Anyway, ang question is to determine the vertical deflection of point B. So again, we'll be using virtual work dito ha. So madali lang, you have in actual truss, and then you also have a virtual truss. And then the load in the virtual truss is the deflection or is equal to a unit load. Ilalagyan natin ng unit load yung virtual truss. Same with the assumed deflection natin. For example, dito, I think we can assume na ang deflection ng B is downward. So meron tayong virtual truss, which is, ito yung nasa solution ko. Meron tayong virtual truss, tapos ang load is actually 1.0 downward din. Again, the load will be on B kasi we want to solve for the displacement man sa B. So, ang gagawin lang natin is to solve for the actual truss, actual bar force sa truss, and then we will also solve the virtual bar force sa truss, and then we will multiply, di ba? Meron tayong general equation, SUL, di ba? SUL over AE. So, kunin lang natin yung actual bar forces and virtual bar forces. So, anyway, ang inuna ko is yung virtual bar force kasi baka may mga zero bar forces dito para ma-skip na lang natin. But anyway, I think walang zero bar force dito. Sige, so proceed tayo. First, by the way, notice, dalawang hinge yan, no? So hinge dyan. You might be tempted to solve the reactions first, but no need ng isang reaction kasi if you will try to look at the problem, you can actually consider joint B first. Diba? Pag consider mo sa joint B, after that, you can actually consider joint C, and then after considering joint C, I think masusolve na lahat by considering joint B and joint C only. Sige, so ang ginawa ko first is to consider joint B. Otherwise, if I will consider joint C, medyo mahirapan tayo na kasi tatlo yung unknown. However, joint B, dalawa lang yung unknown, which is BC and AB. Sige, so after considering joint B, ito yung free body diagram ng joint B. Yan. You can actually sum up forces vertical to solve for CB directly. So sum up ko ng forces vertical, upward equals downward. Looking at the figure, the upward force is the vertical component of CB. So that is CB sine 45 degrees. However, instead of using sine, I used opposite over hypotenuse considering this triangle. Ang opposite side of the theta is actually 2, while ang not opposite over adjacent, opposite over hypotenuse pala. And then ang hypotenuse side is actually 2 square root of 2, or yung di ba, C squared is equal to A squared over B squared. Sige, so summing up forces vertical, ang upward is the component of CB, and then ang downward is only 1. So you can actually easily solve for CB. Simply divide 1 with 2 over square root of 2. So you have CB equal to 414. After solving for CB, we can now consider joint B pa din, and then sum up tayo ng forces horizontal to the left equals to the right. Now looking at this free body diagram here, ang to the left is actually AB plus, okay, AB plus the horizontal component of CB. So since same sila na direction, we can say that AB must be equal to the horizontal component of CB. Kaso nga lang negative. Di ba? Kasi they are on the same direction man. So parang ang equation natin will be parang ganito, no? AB plus CB. Di ba? Ang dalawang yan, that is both to the left, must be equal to the right. Looking at the figure, wala namang force to the right dyan. So this must be equal to 0. Okay? So yan, equal to 0 yan. Meaning, you can actually just solve AB. AB is simply equal to, ito yung CB, 2 square root of 2. However, negative yan kasi you need to transpose it sa kabila. Okay? So anyway, ilalagay ko lang to dito para di kayo manito. This is actually summing up forces horizontal. Sorry. So yan. Oops. I think pwede natin ng ganito. Yeah, so we have AB equal to negative 1. So after considering joint B and solving for BC and AB, we will actually now consider joint C. Looking at joint C, ito yung forces acting on joint C. We have CD, AC, and CB. Now, meron tayong CB kanina, di ba? Na-solve natin, which is 1.414. The only unknown will be CD and AC. Okay, again, considering joint C, you can actually sum up forces vertical is equal to 0, upward equals downward. Notice, the only downward force is actually the components of AC and AB. So, bale, downward, so meaning the component of AC must be equal to the component of CB. And then notice, same sila ng ng inclination. So, dapat equal sila. However, although equal sila, dapat opposite ang sign para equilibrium. Otherwise, hindi yan equilibrium if they have the same sign. No? So, again due to symmetry, equal sila. But if you are summing up forces vertical, bali ang equation natin will be AC multiplied by yung, again, ito, 2 square root of 2, and then plus another component of CB, vertical component of CB. And then notice, sa figure na yan, walang, nyo, sa free body diagram natin na to, walang upward force. So, this must be equal to 0. Okay, notice that itong 2 square root of 2 and the other 2 square root of 2 will actually just cancel out, leaving AC equal to negative CB. Okay, so I hope okay tayo for for AC. Next, na-solve na natin ang AC, we need to solve for itong OC. Okay, or ano ba yan? Hindi pala, that's actually D. So, CD pala, kailangan natin ng CD. So, to solve for CD, considering this joint, sama ka ng forces horizontal. To the right equals to the left. Ang to the right, we have CD. Ang to the left, we have CD and the component of AC. Kaya yan, CD plus the component of AC. Now, that must be equal to the force to the right, which is the component of CB. Okay, so with that, you can actually now solve for CD kasi ang AC, na-solve na natin, ang CB, na-solve din natin kanina. So, CD is now equal to, minus lang natin, we have 2. Okay? So, after that, pag meron ka ng bar force due to the vertical thrust, ang next na gagawin mo is actually to solve for the bar force due to the actual load, which is itong 100. Sige. So, anyway, ang ginawa ko na lang dito, if mapapansin ninyo, instead of solving again the bar forces here, I noticed na the only load is actually also 100 kilonewton. So, ang bar force na makukuha ko, actually the same lang kanina, except instead of 1, it will be 100. So, ang ginawa ko na lang, notice, instead of solving again the A, B, C, D yan, actually parehas lang sila ng sagot. Ang isa nga lang is, you need to multiply it by 100 kasi same man sila ng location ng load. So, notice, hindi na ako nag-solve ulit ng actual bar force. I just multiplied the virtual bar force by 100 kasi same lang naman sila ng sagot. Okay, so kaya baka magtaka kayo, saan galing yung AB squared? Actually, that is AB, actual bar force, multiplied by the small AB, which is, let's just say, ang small AB is the virtual bar force. However, ang nasolve ko so far sa problem is only the virtual bar force. And then you will ask, sir, bakit hindi ka nag-solve sa actual bar force? Actually, I don't need to solve kasi same lang sila. I just need to multiply it by 100. So, bale, ang CB instead na 1.414, 1.414 yan sa virtual. But pag sa actual, that is actually 141.4. Parang ganun. Okay, so I hope okay tayo ha. So, kaya, instead of solving again, nag-multiply na lang ako. Bale, ang ginawa ko, AB times AB na lang. But, ang isa, actually, that's AB times 100 AB. Okay, and then I just factored out AB for the whole term. Kaya yan. So, again this is bar force plus the virtual bar force times the length. Anyway, the length, wala namang problema. I think given man sa problem. Anyway, our answer is 29.14. Let's try to check daw. Again, over AE na. A is 400. Modulus elasticity is 200. Check na natin. Notice, meron ba tayong 29? Walang 29.14. And then again, baka di kayo maniwala nun na yan ang sagot. So, ang ginawa ko, I actually used a software to check kung saan ako nagkamali. However, okay naman. And then I noticed then, using the software, notice na tama naman yung sagot natin. This is B, node 2. Ang deflection actually sa B, vertically, that's actually 29.1 sa kanya. Or this is actually in M, kaya 0.029. Okay? So, supposedly pala, siguro, tingnan nyo, this is 12.1, which is nandito sa choices, 12.07. So, most probably, ang tinanong pala dito is not the deflection at B, but rather the deflection at C. Notice kasi ang deflection kasi sa C is actually node 3. Notice sa node 3, that's negative 12.1 or 12.07 siguro. Yan. Okay, but however, tama yung sagot natin kasi ang tinanong is deflection man sa B. So, yan yung sagot, 29.14. Baka kasi magtaka kayo, bakit? Nagkamali lang ata ng tinanong sa problem. So, dapat ang tinanong sa problem is the displacement at node 3 or displacement at at point C. Sige, so same pa din. If you have any questions or clarifications with regards to the solution, please don't hesitate to comment down below. Again ang solution na gagamitin niyo is ito. Itong pinakita ko sa inyo, this is just a checking. This is just to prove na tama yung sagot natin, which is 29.14, even though wala sa choices. So, I conclude no na baka, I can say no na baka mali lang yung tanong instead of B. Actually, ang tinanong is the deflection at C. Sige, so salamat sa panonood and see you sa next video natin.